Hi everyone, it's Math with AUP. Another frame based on second year past paper questions, especially from Federal Board, or you can say Punjab Board. Question number one is based on limit. A good question, a googly type question. Limit x tends to 1 overall square root 1 minus x divided by 1 minus root x. There are two broad categories of limit. Any number 0, 1, 2, 3, pi, pi upon 2 and infinity, positive or negative. These are the two broad categories of limit, either based on any real number or positive infinity, negative infinity, sometimes both. If the case of real numbers, put direct limit, if denominator doesn't vanish, it's our answer. If our denominator is not equal to 0, it is our answer. Put direct limit. If denominator is 0, then we have to remove 0 from the denominator. Our denominator doesn't vanish. At high level mathematics, these are known as singular points. Some are removable singular points, some are regular singular points, some are permanent. Whatever the case, our focus is on if denominator does not equal to 0, it's our answer. Number one. Number two, overall radical result doesn't be negative. Why? We are dealing with a real valued function. And log is defined for positive quantities. Put direct limit. If denominator is not 0, it's our answer. If denominator is 0, then try to remove it. Okay. Limit, if we put 1, 1 minus 1, 0, so we cannot divide with 0. You have to take care of this thing in case of continuity, discontinuity, function is defined, not defined, or in case of limit. For continuity, discontinuity, function is defined, not defined, or limit. You have to take care of this, or in domain and domain. Denominator doesn't vanish. Here denominator vanishes, then we have to switch over to another technique. If I write 1 square, instead of x, let me write root x square over 1 minus root x. Okay. Factorize difference of 2 square, a minus b, a plus b. We have limit x tends to 1. We have 1 plus root x times 1 minus root x divided by 1 minus root x. Okay, cancelled out. Limit x tends to 1. We have 1 plus root x. Now there is no more denominator. Denominator altogether removed. Now put limit 1 plus root 1. It's 1 plus 1. Under root 2 is our answer in that case. Such type of singular point is known as a regular singular point or removable discontinuity. Continuity, but removable discontinuity. Okay, now we have sorted out what is our limit. X tends to 1, root 1 minus x divided by 1 minus root x is equal to under root 2. That's our answer. In case of limit, defined, not defined, domain, continuity, discontinuity, denominator doesn't vanish. Because we do not divide with 0. Okay, moving to second question. That is, find the derivative of sine inverse root a times x. It's a simple one, but there's a tiny logic in that question as well. Derivative of sine inverse or arc sine root ax with respect to x. Normally, student mug up, cram, memorize, that is the formula always. 1 minus 1 minus x square. Sine inverse x, differentiation of sine inverse x is this. A student is familiar with this one. There is x. What I write, what I preach, I explain this formula as sine inverse of, I used to write angle times differentiation of angle as well. Sine inverse angle different. Okay, let me clarify the situation. Instead of x, I write angle square. I write angle square multiply by multiply with the differentiation with of angle. That's my strategy. That's my strategy to handle such type of question. In exams, simple inclination is not present. Angle is cumbersome, tedious, some multiple, some divisible of any particular thing. So I write this 1 over 1 minus, instead of x, I write angle square and introduce derivative of angle with respect to x. Okay, if you follow this strategy in sine inverse, cos inverse, tan arc sine, you are going to work wonders. 1 minus, what is our angle? Root ax square. And then differentiate root ax. Differentiation of root ax is 1 upon 2 times root ax. Whatever is in the inside, a times x. Differentiation of x is 1. Okay, let me explain how I handle under root. 1 upon 2, whatever is in the square root, write in denominator. 1 over 2 under root x, 1 over 2 under root x root, 1 over 2 under root x. Whatever is inside the root, differentiate a times x means 1. So we have a over 2 root ax. A over 2 root ax. Same is the case here. Look, one more tip. A over root a, it's equal to root a. Root a divided by a, it's equal to 1 over root a. By simply rationalization, or you can keep these things in mind to such type of question. A under root a, it's equal to under root a. Under root a over a is equal to 1 over under root a. Okay, let me sort out this question. 1 upon 1 minus square root cancel, it will become ax times a over 2 times ax. Now this situation prevails. I can write 1 over 1 minus ax times 1 upon 2. Here remains under root a, there comes only under root x. That's our final answer. I have cancelled out. A over under root a is equal to under root by rationalization. By simple rationalization, or you can write substitute 1 from 1 upon 2 from 1, substitute 1 upon 2 from 1, you will get this one. It's mine answer. It's mine answer. Or it can be written as root a times 2, right, in single and root x times 1 minus ax. It's our answer. It's our answer. Let me check. I am in the frame. Okay, okay. Let me write this step here. Here, under root a over 2 times under x times 1 minus ax. They are both they are both in radical sign. They are both in radical sign. I have multiplied. I have multiplied. I have multiplied. It is not in the frame. That's why I have checked and cancelled it out. Okay, that's our answer in that case. Option number D. In that case, option number C. Okay, cool. Moving to another good question. Definite integral as well as the definition of absolute value, modulus value, absolute value. And limit is negative 1 to 1, negative 1 to 1. We are familiar by the definition of modulus or absolute function. It gives us positive when x is greater than 0. It gives us negative value when x is less than 0. Okay. Here, question number 3. Minus 1 to 1, x plus root x dx. Integrate from minus 1 to 1. Don't forget, mod x is equal to x if x is greater than or equal to 0. Mod x is equal to negative x if x is less than 0. So utilize this fact here. We have minus 1 to 1, minus 1 to 1. Just split it up. A negative portion of limit minus 1 to 0. Same x plus, whenever our interval is negative, x is less than 0, take the mod negative 1. It's minus x dx plus 0 to 1, 0 to 1, it's x plus, whenever limit is greater than 1, greater than 0, we have to introduce positive x times dx. Okay, cancelled out, it's 0. What do we have? 0 to 1, x plus x, 2x dx. Integrate 2x square over 2 plus c. Put limit, upper limit minus lower limit. upper limit minus lower limit. X square means here put upper limit minus lower limit. What's x? 1, upper limit 1, lower limit 0. CC cancelled out. 1 square means 1. 1 square means 1. 1 is our answer in that case. So our option is 1. Look at this. Look at the blend of the selection. Look at the selection, how it has been blended. Minus 1 to 1. Don't forget to utilize modulus. Don't forget to utilize modulus. These are the Achilles heels of a student. Achilles heels of a student. Pick another trick with this. Okay. Moving to question number 4. 4. We have cot ln x over x dx. Look, cot inclination is ln x. Cot inclination is ln x. It's not a double function. It is a single function. It is a single function. It is a single function. How to handle this? Let me write cot inclination ln x over x can be written as 1 upon x dx. Now look at this. If we take this one function, it's our derivative. Suppose this quantity, it's equal to y. Y is equal to ln x. Then dy is equal to 1 over x dx. Put both of these values here. It will become cot y and it will become dy. Cot, we have supposed, assume y is equal to ln x, dy is equal to 1 over x dx. Instead of 1 over x dx dy, integration of cot is ln sin y. ln sin y plus c. What is the value of y? We put ln value of y is ln x plus c. Or one can prove what is integration of, how integration of cot is sine. One can write cos x over sin x, cot x over sin x. This is our function having power 1. Function derivative means it will become dy y. 1 over y is equal to ln y. We put value of y. Ln y means sin x, ln sin x. That's the way. In the same fashion, one can prove integration of 10x is equal to ln x. 10 can be written as sine over cos. Differentiation of cos is negative sign. So there's deficiency of minus, right? Minus 2 times, divide and multiply, or 2 times, minus sin x dx over cos x. Look at this function having overall power 1. If we assume dy over y means minus is present there, ln y. We put the value of y, ln y is cos x. Now look at this. Coefficient can be converted to power. Coefficient can be turned into positive power because of, owing to the virtue of log. It can be written as ln cos x minus 1. ln 1 over cos means, okay, let me write 1 over cos. 1 over cos means ln sec. That is the way to prove integration of 10. Okay, here we assume ln x is equal to y. 1 over x dx is equal to dy. Cot y dy. Cot y means integration of cot y is ln sin y. We have proved as well how. Okay, proceeding one step further, ellipse. Another elegant question, less familiar, less popular. What is the area of ellipse? Area of ellipse. Simply, area of ellipse. Equation is x over 25 plus y over 16 is equal to 1. It's the equation of ellipse having center at origin, major axis along x-axis. 25 can be written as 5 square. 16 can be written as 4 square is equal to 1. So here A is equal to 5, length of semi major axis, length of semi minor axis B is equal to 4. Area of ellipse is given by pi times AB. Pi times AB. What values? Pi times 5 times 4. 4 5 the 20 pi square units. 20 pi square units. Some literature also writes this as 2 pi pi a plus b upon 2. Some right here, we write pi times ab, it's a good one strategy. Pi times ab, pi times ab is a good approximation for the area of ellipse. Look at this, pi ab. We are familiar, if a is equal to b, if a is equal to b, then our equation turns to be x square y square over, it's also a square, means x square plus y square is equal to a square. Now it's equation of circle. Equation of circle, center at origin radius a. If I put both a and b together, it will become pi a square, pi a square, which is equal, which is area of circle, which is area of circle, which is area of circle. So pi a b is a good approximation, efficient approximation for the area of ellipse. Area of ellipse is given by pi a b. Question number 6. Question number 6. For what value of alpha the vectors are parallel? The vectors of parallel. We have already handled both. When vectors are parallel or perpendicular, it is based on parallel vectors. When two vectors are parallel, when two vectors are parallel. Let me give you a good idea. A1i, A2j, A3k, and B1i, B2j plus B3k. It's their ratio, corresponding ratios are equal. A1 upon B1, A2 over B2, A3 over B3 is equal to same value. Any scalar, or one can write B over A1, B2 over A2, B3 over A3. These ratios are same. These ratios are same, identical. So we have given the question. We have given vectors 6i minus 8j minus 2k is parallel to, let me write the symbol of parallel, 3i minus 2 alpha j minus k. Okay, cool. Take any, we have to take j anyhow. We have to take j anyhow because we have unknown alpha in j. We have unknown alpha j. Compare 6 over 3 is equal to minus 8 over minus 2 alpha minus 2 over minus 1. Take any two. Either this you will get alpha. Take these two, you will get alpha. Okay, let's see and find out how. 6 over 3 minus 8 over minus 2 alpha. Cancelled out, apply table. It will become 2, 4 over alpha. Solve for alpha. Shift alpha on the left hand side, 2 on the right hand side. Alpha is equal to 4 over 2. Alpha is 2. Alpha is 2. If you take these two quantities, you will get the same value. Let's see. Let's check. Minus 8 over minus 2 alpha is equal to minus 2 minus 1. Cancelled out, cancelled out. Apply table. 4 is equal to 4 upon 2 alpha is equal to 4 upon 2 alpha is equal to 4 upon alpha only. We have applied table here. 4 remains here. 4 alpha there, 2 there, 4 over 2 is equal to alpha is 2. Alpha is 2. That's the same study. Their ratios, A1 over B1, A2, B2 are same in case of parallel. In case of perpendicular, we are familiar, their dot product is equal to 0. When vectors are perpendicular, their dot product is equal to 0. If vectors are parallel, then their corresponding ratios, I with I, j with j, k with k are same. Okay, cool. Moving towards question number 6. For what value of k the slope of the line passing through the given point 73 k minus 6 is minus 1? For what value of k? Simple question based on the formula for slope. Slope, also known as gradient. First possibility to find slope when we have given 2 or more than 2 points. Difference of ordinate divided by difference of abscissa, or simply y2 minus y1 over x2 minus x1. From the line itself, if the line is written in general form, then formula for slope is negative times coefficient of x divided by coefficient of y, or if you can transform the equation in y is equal to mx plus c, slope intercept form. slope intercept form. This is our slope. And the fourth advanced possibility, we can manage the slope by differentiation. We can manage the slope by differentiation. Another possibility, when we have given angle, we can manage slope. M is equal to tan theta. 2 are more than 2 points, y2 minus y1, x2 minus x1. From the line itself, how minus coefficient of x divided by coefficient of y. If we transform the equation in slope intercept from y is equal to mx plus c, that's our slope. By differentiation, when we have given angle m is equal to tan theta. In that case, we have given 2 points. It suits us. It fits us. It is good for us to work with this. Okay, cool. What we have given 2.73 and k minus 6, and slope is given to us, it's equal to minus. It's up to you. Take them x1 y1, x2 y2. It's up to you. It's x1 y1, then it's x2 y2. Put here minus 6 minus 3 over k minus 7. Slope is given to us, it's minus 1. Solve for k. Minus 6 minus 3 minus 9, k minus 7 is equal to minus 1. Shift k minus 7 on the right hand side in multiplication, it will become minus k times 7. Minus 9 minus k minus plus 7. K on the left, 9 minus 9 on the right. We have k is equal to 7 plus 9. K is equal to 16. K is equal to 16. Okay. Let me verify for you as well. Minus 6 minus 3, value of k is 16 minus 7. Minus 6 minus 3, it will become minus 9. 16 minus 7, 9 cancelled out. Our slope is minus 1. We have done wonderful job. Moving towards the final question based on mystery or trickery of straight line. Let me give you a background of straight line. First, we have given symmetric form of straight line. Symmetric form of straight line in 2 dimensions. It can be written as x minus x1 over cos alpha is equal to y minus y1 over sin alpha is equal to r. Or some writers write shift r there, x minus x1 over or cos alpha y minus y1 is equal to r sin alpha. Symmetric form of a straight line. The second one is two intercept form. Two intercept form is given by x over a plus y over b is equal to 1. Almost equation of ellipse without square. Almost equation of ellipse without square. Where x intercept is a0 and y intercept is 0. X intercept is a0, y intercept is 0. Then slope intercept. I have just mentioned slope intercept. Slope intercept means y intercept. Y is equal to mx plus c. This is our slope. And c is our y intercept. C is our y intercept. A normal form of straight line. Normal or perpendicular form. Normal or perpendicular form. Normal or perpendicular form is given by x cos alpha, y sin alpha is equal to p, where alpha is the angle measured counterclockwise from positive x-axis. From positive x-axis, and p is the distance from origin. Perpendicular distance or distance from origin. Perpendicular distance, shortest distance or distance from origin. Distance from origin. Okay, cool. What we have given? We have given x over p sec alpha, y over p cosec alpha. We have to hunt. It is what form? It is what form? Let me write for you this. X over p sec alpha plus y over p cosec alpha is equal to what? We are familiar. 1 over sec can be written as 1 over sec means cos alpha. 1 over cosec means sin alpha. Sin alpha is equal to 1. Taking LCM and moving p on the right hand side, we have x cos alpha plus y sin alpha is equal to b. That is our normal or perpendicular form. That is our normal or perpendicular form. That's my tiny effort, guys, to inculcate in you some abilities, how to solve MCQ, subjective, whatever the case is. Mathematics is very simple, but work with clarity. Clarity, not mug up, don't cram. It's all by itself. Text.